Very good to see everybody here. As you can see, I'm Rob Lewis. I'm from Ferroglobe, technical marketing manager there, and I've been with them for about 5 years. I was doing this stuff with Silica Fume for a very lot longer than that, and I have not been doing it for a millennium, but we are going to talk about concrete that will last a millennium. And when we're talking about sustainability, I think 1,000 years is pretty good on the sustainability side. What happened was, back in 1988, a question went round in the state of Colorado, and they were looking for some concrete. And the guy said, we want some concrete. We're going to build a thing called a stupa. I'm going to build this stupa up in the mountains, and we're going to want it to last for 1,000 years. Can you design the concrete for us? And people said, well, first off, they said, what the heck's a stupa? And it's a spiritually empowered monument. It liberates you on seeing it. You know, when you rest your eyes on something green, they say, and you calm down. This is to liberate your spirit when you see this building. As you can see, it's to honor the founder of the Shambhala Mountain Center. You can see there's a little image of it just there. You'll get a much better picture of it later on. So they wanted to build this, and they wanted this to be very much in honor of this gentleman, and they wanted it to be really good. But, as you can see, it's up in the middle of nowhere. I think I've got a laser over here. They let me loose with the laser again. It's up in Red Feather Lakes, up there. Those of you who know that, there's Fort Collins, there's Cheyenne, and here's Denver down here. So it's right up in the middle of nowhere. There is no road that goes all the way up, so there's no way they were going to get the ready-mix truck all the way up there. It's at 2,600 meters or 8,500 feet for people who talk in old money, and it's right up there. The local ready-mixer is in Fort Collins, so yes, that's down here, but it's got to get from here all the way up to there. And yes, don't forget, we want it to last 1,000 years. And it's being built by volunteers, not professionals. So it may take some time, like years. This is not going to be a quick turnaround. This is not going to be an easy project. Those of you who know Colorado and the Rockies, it can be a bit rough in winter. There's not a lot of roadway, as we said. Access is a bit difficult. There are bridges you can wheel the wheelbarrows across and get it there. But obviously, during the summer, it's going to be wonderful. It's going to be a nice place to do some work and produce this wonderful building. Okay, so let's have a think about it. We want to make this a good mixed design. We want to make it a lasting mixed design. We know we've got to get a fairly good strength, 6,000 psi at 28 days. Oh, mustn't forget the air. I know in America we put air in virtually everything to make it easier to use, but this is specifically for freeze thaw. There's not going to be a lot of freeze thaw, because once it gets cold up there, it stays pretty cold. So, but there's going to be that combination to keep the freeze thaw off it. We'll see the targets in a little time. Don't forget that 1,000-year lifetime. As I said, it's going to take about an hour for the ready-mix truck to get to the bottom of the hill. Then it's got to be manhandled all the way up. There's going to be some big blocks to pour. So these wheelbarrows are going to have to do double time on getting the concrete into the pour. There's going to be some delicate fascias to cast as well. So we're going to want a creamy mix with good workability to get those fascias to come out. And it's going to need to be workable on site for at least a couple of hours or so. In that time frame, you've got to be very careful about losing the air. Yeah? If you mix it too much, if you leave it to sit, it's going to lose that air. So what can we do about the air? Remember, this is 1988. And so they said, right, got a good amount of fly ash in there to give it long-term strength and durability. We'll add the silica fume. We'll seal up that concrete. We'll give it a bit of extra strength, or resistance to water, chloride, sulfate resistance, enhanced durability. Triple blend, of course, that fly ash and silica fume will give you a nice creamy paste, so you'll get a pretty good finish to the fascias, and it's going to resist the damage. And they came back and said, yeah, but what about that air? What are we going to do about the air? And, well, it just so happens there was a new product just on the market called Micro Air in 1988, the first synthetic air entrainer. They said, yeah, okay, we'll give that a baptism of fire. We'll see and make sure if that works. And target was 100% freeze-thaw resistance at 300 cycles. They achieved over 500 cycles. Like I say, up there, it's going to not go through the 500 cycles. It's going to go up to down to the cold and stay at the cold until the spring comes around. So this is very good. This is going to be really good for the temperature it's going to be in. So there you go. Those of you that work in both sets of numbers can appreciate the mix design there. So you've got 11% replacement of the fly ash based on the total cement content, 9% addition. So it's a good mix there, good strong mix. You can see high range water reducer. The aggregates are in there to the yield, but 5% air entrained, 0.35 water cementitious ratio. It's good. It's not low, it's not high, but you can see that very much that 28-day strength, 60 megapascal, 8,700. So they're well past it on the 7th day. The target 6,000, well past it on the 7th day. So this was a good quality concrete for them to do and for them to use. And we're talking about sustainability. So did anybody think about the carbon footprint in 1988? No. Nobody was thinking about that. So let's have a think about what we can do. 35 years ago. So given some rough numbers for the contents, you can come up with, it looked at about 417 for the triple blend. Much better than pure. The silica fume and OPC, the binary blend, quite high. The fly ash binary blend, quite high. You do get that reduction when using both of those materials in that blend. So the triple blend had the lowest carbon footprint. Now, I know you will say, hang on, 700 pounds per cubic yard, that's not exactly low. Remember, this concrete is due to last 1,000 years. Relative carbon footprint is minimal, almost negligible. It's going to be built once and sit there for 1,000 years, hopefully a lot longer. But it didn't matter that it was around that mark, around your sort of 40 megapascal concrete that you produce now, your standard OPC mix for your housing and low-rise. This is the sort of level, but it was reduced. And yes, they made some big, solid pieces. Very nice, very sharp edges. Look at the edges you've got on there. That mixture of the fly ash and silica fume giving you a very tight edge on all the corners, on all the edges. Nice, crisp finish to it. If you're on the inside there, you can see where they did the inside. It's big and it's blocky. Remember, we said this is being built by volunteers. There's not going to be an awful lot of finesse to the construction or the design. It's meant to last 1,000 years. It's going to be big and solid to do that. There you can see the quality of the concrete there. That was the big pieces, the big slabs, the finishes. But yes, they got that finish. How's that for a cast in situ finish on that decorative piece there? That's really quite good. And even more, when they got to some of the actual fascias, to some of the edges, you can see the pattern that's in there. And I'll give you close up. Look at this. You can see that fingers here, behind, and everything else. That's a very, very tight finish on that concrete, very decorative, and still able to resist the temperatures and everything else that's up there. Now, of course, they didn't just leave it as plain concrete. They did colour it. They did do the exterior finishing. So there you can see the colours where they painted it. Yes, good quality cover to make sure they got resistance as well. Some carbonation, they may have been worried about that. They wouldn't have got that with the triple blend they were using anyway. But give it that colour. You can see the colours they've used on the other decorative pieces as well. And That's what the finished item looks like. Great Stupa of Dharmakaya. Remember where it is? 2,600 meters up, 8,500 feet up in the Rockies. It took 15 years to build. So it was volunteer workers. It took 15 years to build it, but the result is, say, truly impressive. It's a very elegant, very beautiful structure. And I think that would calm your spirit when you saw that amongst the green as you looked up there and see that particular structure. Yes, it does probably stand a very good with its lasting 1,000 years, even with that carbon footprint that it had, that can be classified as sustainable construction. And that's just a little taster of the sort of thing that we're doing, because that's the end. It's just a nice, quick presentation of something that's really nice, but that's that key point. Sustainable concrete, triple blend, does the job.